Hi 6th graders, this is Mrs. Gall. Today we're starting our unit over geometrical figures. Get your notebook open to a fresh page and put this title at the top, Triangles. When you're ready to continue, press play. What do you already know about triangles? Maybe you know that there are 3 sides to every triangle. If there's 3 sides, that means we also have 3 angles inside of each triangle. And we also have 3 vertices. Singular would be a vertex. That's where 2 sides meet and create that corner. There are different types of triangles, and we can classify them by their sides and their angles. In all triangles, their sum of the angles will always be 180 degrees. Let's try finding the measurement of a missing angle, knowing that each triangle's angles will add up to 180. So here we see that angle R is 89 degrees. Angle Q is 54 degrees. So how would we figure out what the missing angle X would be? Well, we would add up the 2 sides we know along with the unknown and set that equal to our total 180. Then we can solve this like an equation. Add our 2 terms on the left that are constants together. We get 143. Now we want to get x by itself. So to get rid of this 143, we would subtract both sides by 143. 180 minus 143 will give us our answer for x, which is 37. We could double check that our answer is accurate by plugging it back in and making sure all of those angles add up to 180, which they do. You try that on this one. Set up your equation with all 3 angles equal to 180. Add the 2 sides you know, 61 plus 74, we get 135. Solve our one-step equation by subtracting both sides by 135. You get x equals 45. Try this one on your own. 45 degrees. Think about what this box would mean. Have you seen that before? That means our angle is worth 90 degrees, and then our unknown. Figure out what x would be. Add up the 2 sides you know. You should have gotten 135 plus x equals 80. Subtract 135 from both sides, you get 45 degrees. That's how we find a missing angle measurement in a triangle. We can also use ratios to find angle measurements. If we have a triangle that's called triangle ABC and the ratio is 1 to 3 to 8, what are the measures of each angle inside of that triangle? We set this up by taking the 3 ratios, or all of the numbers in the ratio that we were given, and set an x next to them. X is the angle measurement for each piece. So if I have 1x, that's the same thing as x. My next number in my ratio is 3, 3x plus 8x. That should all equal 180. Then we solve that like we would an equation. We have x plus 3x plus 8x all on one side. So we can add those together to get 12x equals 180. Just like a one-step equation, we can divide both sides by 12. We figure out that x equals 15. Does that mean all of our angles are 15 degrees? No, that means 1x is worth 15 degrees. So now we know what our first angle measurement was, 15. Now we can figure out our second And our third by plugging a 15 in for x. So 3 times 15 means our second angle measurement would be 45 degrees. And 8 times 15 means our last would be 120 degrees. So when you are given a ratio, you can place an x next to each value, add them together, set them equal to 180, solve for x, and then use that to help you figure out what each angle's measurement would be. Let's try one of those on your own. The measures of the angles of triangle ABC are in the ratio 1 to 3 to 6. What are the measures of the angles? Just like our last example, set each of those numbers up next to the letter x. Remember that 1x is the same thing as x. And then all triangles will have total angle measurements of 180, so we always set that equal to 180. We add our x's together. 1x plus 3x plus 9x gives us 10x. And now we solve for x by dividing both sides by 10. X by itself would be worth 18. So that means x, the first number in our ratio, 1x, is 18 degrees. 3x means we would plug 3, or we would take our 18, plug that in for x, and take 3 times 18, so that would give us 54 degrees for the second angle. And our last 6 times 18 would give us 108 degrees. Let's practice classifying triangles. Triangles have a first name and a last name. Their first name is when we classify a triangle by their angle size. We have 3 ways that we classify by angle size. So we have an acute triangle. That means if this triangle has all acute angles, acute meaning less than 90 degrees. So there's no angle measurement in this triangle that's over 90 degrees. Pause and write that example down. Our next angle size is obtuse. Obtuse means one of our angles is over 90 degrees. So right here we have a 105 degrees angle. So that is greater than 90. So this is an obtuse triangle. Pause and write that down if you need more time. Our last classification is a right triangle. This is where we have one right angle, one 90-degree angle. And we usually see this perfect box that indicates we have a 90-degree angle. Pause if you need more time writing down the angle size classifications. Now we're going to move on to the last name that triangles can be classified by, and this is when we classify by their side length. Before we continue, one important word to remember is congruent. Congruent means equal. An equilateral triangle is when all sides are congruent. All sides are equal in length, and we a lot of times will see a marking that indicates all sides are the same. In this case, we have one tick mark on each side of the triangle that's telling you that those are all the same length. In isosceles, you have 2 eyes, and an isosceles has 2 sides that are congruent. So here we can see the tick mark on 2 sides of our triangle telling us that those 2 sides are equal in length. Our last is scalene. Scalene is no congruent sides. So you can see that there's no tick marks indicating that any of our sides are the same in length. Pause if you need more time to write that down. So we can classify by sides, angles, and sides. So let's do both. So let's first classify this triangle by its angles. What do you think we would say for angle classification for this triangle? I see a 90 degree, so this is a right. And now let's classify by sides. Do you see any sides that are showing that they are the same length? Do you see any of those tick marks? No, so I would call this a right scalene triangle because we have one right angle and no sides are the same in length. What about this triangle? First, let's look at the angles. I don't see a 90 degree. I don't see anything above 90 degrees. So this is an acute. And then let's look at the side lengths. I have two that are the same. So an isosceles, we would call this an acute isosceles triangle. See how I'm using both terms, the angle classification and the side classification, kind of like a first name, last name. Let's look at this one. Angles first. Ooh, even though I don't know what this value is, I see I have one angle that's over 90 degrees. So right away I can tell this is an obtuse triangle. And then I see two sides that are the same in length. So an obtuse isosceles triangle. What would x be? 120 plus 130 is 150. So x must be 30 degrees to get us up to 180. What about this triangle? Look at the angles. Do you see any 90s? Nope. Do you see anything over 90? No, even though I can't tell what x is, see how it's got a very closed in looking angle? That's telling me it's less than 90 degrees. 53 plus 50 is 103. To get up to 180 from there, I'd be 77 degrees away, so not yet up to 90. So this is an acute. Do I have any sides that are the same? No, so an acute scalene triangle. All right, you guys, that's all I have for you with triangles today. Check in with your teacher if you have any questions.